Hello everyone, this is Natália de Paula from Military Engineering Institute from Rio de Janeiro, Brazil, and today I will present my work entitled of CRITIC-MOORA-3N application on a selection of AHTS Ships for Offshore Operations. It is known that the investments applied in the oil and gas industry are high. With the advent of the new coronavirus pandemic, it can be said that all or most of the industrial and market segments suffered with production and proficiency. The vessels involved in supporting platform installations require large investments. In this context, the present works aim to present a new method to support decision-making using the multi-criteria methodology, where the characteristics of the two already established multi-objective methods were optimized. The proposed method comes from the union of the already established method. Firstly, critique. Criteria importance through intercriteria correlation, whose main objective is to mathematically assign weights to the attributes of the alternatives of the problem to be solved. Moreover, the MOORA, multi-objective optimization on the basis of ratio analysis, whose simple axiomatic allow to operationalize different attributes of the different units of measurements and objectives and to bring a coherent result to the choice. On this way, the method starts by the decision matrix, where the alternatives and attributes as based on information provided from the decision maker. RRG indicates the elements of the decision matrix for its alternative and J's attribute. Thus, N presents the number of alternatives and N the number of criteria. The positive and negative attributes are normalized by equation 2. This normalization is based on the concept of ideal point. Xij represents a normalized value of the decision matrix for its alternatives and J's alternative. Then, the initial matrix of evaluation is converted into a matrix of relative scores with generic elements. By examining the J's criterion, in isolation, we aggregate a vector xj denoting the scores of all n alternatives considered. Employing the dimension n to n and a generic element pj key, equation 3, which is the linear correlation coefficient between the vectors xj and x key, and quantifies the contrast intensity of the correspondent criterion. Xj and x key display the mean of j and key attributes. Xj is computed from equation 4. Similarly, it's obtained for x key. So, we calculate the standard deviation of each attribute by equation 5. Thus, the index Cj is calculated by equation 6. Then, objective weight results by normalizing these values to units according to the equation 7. Now, we apply a second normalization using the Euclidean distance according to the equation 8. Finally, we optimize the calculation using a third normalization. The responses from the prior normalization are added in a maximization equation for positive objectives or in a minimization equation for negative objectives. A survey was carried out with the project team of a multinational provider of oil and gas projects. Just heads up, for offshore logistics is a most indispensable type of vessel for pipe installations. Exploration and production operation is anchor handling tug supply vessel. This ship has a characteristic which has to operate in extreme environments because it has a small body of the ship in contrast big main engines. Table 1 presents the AHTS data according to the mean requirements selected for each criterion by the specialists. Table 2 shows the attributes of the matrix. To facilitate the use of the method, a tool was developed in Visual Basic capable of calculating automatically by inserting the data to be analyzed, allowing the use of the method. The weights are applied in percentage, and then it's possible to calculate the best alternative for the situation in a ranking. Analyzing for this situation the ranking from the CRITIC-MOORA-3N method showed that alternative 5, AHTS 5, presented the most adherent characteristics to the requirements of the decision makers presented on this case study. We can conclude the method proved to be objective and practical. Its multi-objective feature allows its application to any business areas, even if the problem presents objectives from different segments or measurement units. The mathematical evaluation of the importance of criteria provides security and impartiality of the parts of the stakeholders, as it avoids a subjective evaluation of the attributes. Thank you for your attention. I am available for your questions.